Please note that the material in this communication is subject to copyright under the Intellectual Property Act No. 36 of 2003. Any further reproduction or communication of this material is allowed only to the extent provided in the Act.
First of all, I would like to welcome you all to Faculty of Engineering and to your first ever lecture in the Faculty of Engineering. Although I mentioned this as a lecture, it is not exactly. So what I am planning to do here is just to give you a brief idea about the robo navigation problem. I know that many of you are engaged in mind-blowing discussions and even having meetings to find the solution to this problem. Actually, the main objective of this exercise is not to design a robot. The main objective, or we can call it as a hidden agenda, is to make sure that you engage in discussions and also you try to find solutions to real practical engineering problems. Now, there is a huge difference between the exam problems and engineering problems. The main difference is in exams, usually you are expected to find a solution for a given problem. And also there is a marking scheme, and if you don't follow the marking scheme, you will not get marks. So there are a lot of things of that nature. Unfortunately, due to this situation, we all have started thinking in the same line. And it has, with the competition in the A level, it has gone to extent where now we are becoming some robots, right? We are thinking in the same pattern according to a same marking scheme. So the main objective of this exercise is to take you out of that mentality and give you some experience of how engineers approach problems, how they discuss them, how they generate different types of solution, because for a given problem, only one problem is we have to, that mentality we have to come out, right? So now, for example, recently you may have seen when they are making this highway, there was a tree, right? Some rare species of trees. So the engineer solutions is cut the tree and make the road. That's the simplest and most cost-effective solution. But then there are a lot of other groups, right? There are a lot of other things that we have to consider. So with all those things, finally, the engineers have to come to a certain solution by considering all those factors, right? Similarly, in any of these problems that you get, you have to consider many factors and come to a solution. For example, I was really happy to see some of your discussions and some of the questions that you have raised, right? For example, there are questions like what will happen if a person comes in front, and so many questions. So that shows that we can still think. So the main objective of this exercise is to further improve and enhance that thinking capability. Also, I would like to tell you a little bit of how engineers solve problems, because engineering, some of you think, okay, it's making things or basically technology, but there is more to engineering. For example, at the beginning when I gave this problem, there were a lot of discussions among yourself and many questions were directed at me about making this robot. Yes, it's fun, right? You can make this robot, but there are a lot of people out there who can make robots. I think many of you may have even tried robots at school, right? And also, if you take some student following different streams like technology or NDT, they may be capable of doing it better than you, right? So then, what is the role of an engineer? Of course, engineers learn mathematics. Why? In mathematics, you can try to find solutions to some problems in an easier manner than you do it in the real world. That is why engineers have a heavy mathematics component. And to give solutions to such problems, for example, if you take this particular problem, to find the best way to navigate the robot, because anyone can navigate a robot. That's simple. But how to navigate this robot in the most effective manner? That is the problem that we need the solution from an engineer. So that is where in University of Peradeniya we pitch at, right? Not just making gadgets, but how to apply engineering to solve problems. Okay, so with that, now let us go to this problem. I'm not going to give you a solution to the problem that I have given you, that is to design a robot to clean a hospital floor. But using the same map I have given, I will try to address a different problem, much simpler problem, so that you can get some of the very basic concepts. Now here I have shown the same map I have given to you for the hospital cleaning robot problem. But all the criteria are same, but there is one difference. Here, your final task is to, the robot is at this particular point, shown by red color, and I want this robot to go to the cell mark or the tile mark with blue color, right? So it is not cleaning all these white color cells as given in the previous problem, but navigating this robot from this starting position to this end position. So how can you approach a problem of this nature? Let's see. One of the first tasks of a problem of this nature is representing the problem using some mathematical concepts that we know. Right. So the basic steps that we are going to discuss is, the first one is representation of the problem, right? So when I mention mathematics, don't panic, right? Mathematics is just another way of representing a given thing. And in future, you will realize that many wonderful things are done using mathematics. For example, if you take from mobile communication to robotics to space exploration, many things, there are a lot of mathematics involved. And that's why we emphasize on the importance of engineers learning mathematics. So let us see representation of this problem. How can you represent a problem of this nature in a mathematical domain? Okay, first, let us consider the map. How can I represent a map of this nature using some of the mathematics we know? Of course, there are many ways, but one of the simplest way that comes to my mind is, so that is very important, right? That comes to my mind, because there can be different ways of different people representing. So you also can think of different ways of representing, right? So how can you represent this map? Well, I'm going to use a matrix. So I think in A levels and also in O levels, nowadays you learn matrices, and you may be wondering, why are we learning these things? Okay, this is one thing that where you can use it. For example, I can represent all these white cells or the cells without obstacles using a number 0. and the cells with obstacles using number 1. So finally, there are 10 rows and 10 columns. So this becomes a matrix. So let me define a matrix called as M, which is actually a 10 by 10 matrix here. And then I can define, okay, zeros are the tiles to be cleaned, ones are the obstacles, right? It is easy as that. Okay. Then also I may need to keep a record of all the clean tiles, right? Because that is important, because you don't have to then clean a tile 2 times or more times, because sometimes, you know, when you navigate through this one, if you come to a corner like this, you have to come back, right? Because there are no other ways to go further from a corner like this. So in such case, on your return trip also, if you clean the tiles, it is a waste of material, and also it is a waste of time, right? So we want to stop that. So I can keep another matrix that, let's call it as C, right? So I define now, right? 0 means not clean, and 1 means clean. So each time you go to a particular tile and clean it, you mark it 1, right? And also this matrix is needed to find whether we have achieved our target. So what is our target? In C matrix, all these cells should become 1. So how are we going to check it? Well, you can find different ways, right? But one method that I like to find is, so when you do this, all the cells where the robot has traveled becomes 1s. And of course, these cells in C matrix, they are 0, right? So what can I do? One thing I can do is I can apply the AND operation between M and C. You know logical operations in O levels and A level, right? So if you apply, sorry, not AND operation, the O operation, right? So you take each cell, for example, you take this cell and also this cell of the M matrix and apply logic O operation. What will happen? If you get logic 1 from one of the matrices, then that cell is cleaned, or there is an obstacle, right? One of the three. So how can you test that you have achieved your target? All these cells becomes 1, so not a single 0, right? So how can I find this? I will check in this one if all is equal to 1, logic 1, then we have achieved our target. Then we can stop the robot navigating. Of course, there is another interesting question that one of you have sent me. After cleaning, don't we have to come back to the initial location? That's a very good question, because in a practical situation, that should be the case. But for this particular problem, I have asked you to forget about that, right? So, because, I mean, after cleaning the thing, coming back to the original position is a different problem, right? There you don't have to make sure that you clean all the time. So, I think with that knowledge, you also can try different methods of representing this problem, right? So I have considered about the representation of the map. Now the next thing is, I want to represent this robot. So how can I represent the robot?
Please pause the video and attend to this activity.
Hope you have found some answer, and let's see how I am going to do this, right? And also I have to stress here, this is how I am going to do it, not necessarily you. You also can try to find different ways of representing. Now when I take the robot, there are two main things that changes with time. One thing is, so robot, first the position of the robot changes. So I need to represent that. The next parameter which changes with the robot is the orientation or the direction, right? Now position can be having two parameters, the x and y coordinates, or we can use the cell numbers. For example, if I number these as rows, so let me 3, 4 up to 10. Here also we have 1, 2, 3 up to 10, right? So let me call this as the row coordinates, so we'll represent it using a variable I, and then the columns using j, right? So for example, if you take this particular cell where the robot is initially, I is equal to 10 and j is equal to 3. And if you take the direction can be 4, right? Up, right, down, and left. So I can represent them easily using a number. So I'll use 1, 2, 3, and 4 to symbolically represent the direction. So in many of the problems, actually the real world scenarios, we are going to symbolically represent. So my variable d will contain, in this particular case it is pointing upwards, so 1, right? Then using all these features, I can make a unique code for each instance of the robot, right? Now for example, here I have to represent the number from 0 to 10. Sorry, 1 to 10. So I need 2 digits. If it is from 1 to 9, I may use only 1, but if I have 2 digits, I can represent from 1 to 99. So I will create a code like this, right? I can call it any name, robot position code or whatever. The first part will be a 2-digit number which will be representing I. So for example, here I can write 10. The second 2 digits represent j, right? So here I can write 0, 3. And finally for the direction, right? Here I can write 1. Now this way I can represent, or I can come up with a unique code for each position of the robot, right? Of course some codes are not allowed, but we will see about those things later. But basically any point I can create a code like this. For example, if you take this one, right, what is the code? The row number is 1, 2, 3, 4, 5, 6, 7. So it is 0, 7. And the column number is 1, 2, 3, 4, 0, 4. And suppose the robot is pointing downwards, so the code will be 3, right? So this particular instance, if the robot is here sometime pointing downwards, you can represent it using this code. Okay. So this is how you can represent the position and the direction of the robot using one unique code. Okay. The next thing that need to be represented is the possible actions, right? Now suppose the robot is in a particular cell like this, a generalized cell, because I stress the importance of developing our solution for a generalized case, not this particular map. So when you are here directed at some direction, some arbitrary direction, what are the possible actions? right? First thing is, we don't do any rotation. So I'll say, do not turn, right? That is one action possible. That means when I give the move command, the robot will move into that direction, right? So do not turn. The second possibility is clockwise 90 degrees, because I told you that we can rotate in steps of 90 degrees. So one possibility is clockwise 90 degrees. Then another possibility is clockwise 180 degrees. Also, I have allocated times here. 90 degrees is 2 seconds, and so this is 4 seconds, and so on, right? Similarly, another possible action is, you can take it, because if I am here, if I want to rotate this direction, I can go to 270 degrees rotation, but I can save more time if I go counterclockwise 90 degrees, right? So basically, these are the 4 possibilities or 4 possible action that we have to decide. Apart from that, in all cells we have the move action, so I will call it as my 5th action, because after rotating or do not turn, we have to move the robot so that it can go to the next cell. And also we have a clean action. In clean action also there's a difference between move and clean, because every cell you have to move, but not necessarily clean, because if you have cleaned that tile before, then we don't need to clean it again, right? So these 6 actions are there, but for our decision making, it is these 4 actions which are necessary. So we will not consider these things for the time, right? Because they will be based on simple logic. Move you have to do every time, so even you don't have to take it for the time calculation, because that 1 second is common for every cell. Clean, of course, there's a difference. Clean, only if you want to clean a particular cell, you have to calculate that time. So we will take these 4, right? Now when you are here, or any arbitrary cell, you have these 4 options. So suppose you are at a particular row number and particular column number, right? So we call it as a state, and also the direction, right? Which is represented using a code like this, right? And then you have possible actions. Action number 1, action number 2, action number 3, action number 4, right? Sometimes all these actions are not possible because of the obstacles or boundaries, right? Now, for example, if I take this particular instance, right? Let's start with this. If my state is 10, 0, 3, 1, then first action, is it possible? Yes, it can go to this one, and it will go to 0, 9, 0, 3, 1. Because the direction is same, we will go. Action number 2. Action number 2 is rotating clockwise 90 direction. So it will come like this. So the result of that action after moving will be coming to this cell. That is 10, 0, 4. Now the direction has changed, it is 2. This one, it is not possible. This one, that also not possible. So these 2 actions we are not going to implement, because one is going out of the boundary, one is direct into a cell with obstacle, right? So this is our input, and these are our outputs. So one main thing that you have to do is develop some function, right? I'm not going to tell how, you have to think, right? If I can develop a function where if I substitute this value, right, it will give me these 2 possible solutions. One solution is 0, 9, 0, 3, 1. The other possible solution is 0, 4, 2. So think of some black box, right? So what you basically do is you have a block like this. You input 10, 0, 3, 1, and as the possible result, I should get 0, 9, 0, 3, 1 or 10, 0, 4, 2, right? So can you think of some possible method here? So that is what I mean by methods. So give it a try.
Please pause the video and attend to this activity.
Okay, let's see, right? So what you were basically asked to do was, right, given the present state, find next possible state. Right? So how can we do this? Of course, there are various ways of doing this, but one way I can do is I can use a table. Now, the present state actually denotes the x coordinate, y coordinate, and the direction, or we can say the row number, column number, and the direction. And when you are moving, the row number, column number, and the direction applies, right? Now, for example, if the present state is 10, 0, 3, and 1, okay? If you apply action number 1, that is do not turn, right? So you are not going to turn anything. Then what will happen to the direction? Yes, so I will take the position and direction like this. So this cell will remain same, okay? But if I apply action number 2, it will turn counterclockwise. So from 1, if you apply the action number 2, it will rotate by 90 degrees. So this will become 2. If I apply action number 3, this will become 3. Action number 4, this will become 4. In other words, I have simplified this problem to something like this. So you have to develop a small black box where you will give the present direction D and the action, right? The output should be the next direction. So I will denote this by the present value, and this is the next value, dn plus 1. So these are just mathematical notation. So I need to find the function for dn plus 1 in terms of the present direction and action. So can you do it? There are various ways of doing it, right? One method is you can prepare a lookup table. So what I can do is I can here put the actions. So you have 4 main action, 1, 2, 3, 4. And here I will put the dn present state. So that also 1, 2, 3, 4. And then I can keep on filling this table, right? For example, if the present direction is 1, that is pointing upwards, right? This is pointing right, this is pointing down, and this is pointing left. And if the action is don't do anything, they will be same, right? That means you are not rotating or you are not turning the robot. If the action 2, that is clockwise 90 degrees. So if the action is clockwise 90 degrees, what will happen? Yes, then this will be rotated by 1 and it will come to 2. So you have 2, 3, 4. And when it is 4, if you have again rotated by clockwise, it will become 1. Right? Similarly, for this one, you have 3, because 180 degrees means this one comes to third direction. So 3, then 4, and this one. So if it is 2, it is 1, right? And 2. Similarly, this is counterclockwise, the other direction. So if it is 1, you will end up with 4. 2, 1, 3, 2, 4, 3. Right? So you can represent this knowledge. So we are representing some sort of intelligence, right? In this symbolical representation. You can represent it this way, or some of you can try to even find the function between these things. For example, for action number 1, if the action is 1, simply dn plus 1 equals dn, right? If action is equal to 1, dn plus 1 is equal to dn. Then if action is 2, dn plus 1 is equal to dn, right, plus 1. You add 1 to here, except this case where it is 4 and this comes 5. So how can I find the solution here? You get 5, but since you have 4, you always divide the solution by 4 and get the, yes, right? So you divide it and get the remainders. So like that you can find different relationships. Similarly, you can find blocks for input in and action, and I want to get in plus 1. What is the next stage when you move, right? Similarly for j also. Right? Now after doing this, for a given state, you can generate different solutions. For example, if you are in a cell like this, it will generate 2 solutions like this. If you are in a, let's say, a cell like this, it will have 4 possible solutions, right? So this block, what this block of thinking will do is, given the action and the present state, it will give you the next possible states. Now this problem is how to select one out of them, right? Now here you have 4. So how can I select one out of them? For that, you have to use some ideas that you have about reducing the cost. Now I have to mention here, I have given you a very complex problem. That is, floor cleaning problem is one of the most difficult problem. The reason for giving you that is to take you out of that exam mentality. That is, there is one possible teachable solution for any problem. No, it's not, right? It is only by engaging in good discussions you can come up with some good solutions. So to make your life little bit easier, I will reduce the complexity of the problem by changing this problem little bit, right? Now let's say it is not a floor cleaning robot, but suppose this robot is supposed to take, because our faculty also have designed several robots like that for the corona epidemic, for Teldeni Hospital. I think you may have seen that in television, right? I will share the video of that with you in a short. So suppose this robot is supposed to take food or medicine from this point. Suppose this is the place the nurses are, and it has to take it to a patient in this particular cell colored with blue color, right? So how to find the best path? Now in the same way that we discussed here, you are generating 2 solutions like this. Now the problem is how to select the best solution out of this. Naturally, we will go for this because we feel that this is closer to the patient, right? But how to make that decision, right? Rather than, that is the key challenge that we find in all these artificial intelligence systems, how to represent our thinking into an algorithm or an equation and so on. So what made us to do this natural selection? Yes, this one is more closer to the patient than this one. So that is the criteria. How do you say it is more closer? If you know the goal, that is where you have to go. We are just subconsciously analyzing this aerial distance. So that is one criteria. So you have two solutions. Instead of going for this, we go for this because it is more closer, right, aerially. Here also similar, right? But you can see if I am here, there are two possible solutions here and here. But if I go here with that criteria, it will fail. So all these solutions are not always going to work. Now, for example, if you take something like Google navigation, in hilly areas where the aerial distance doesn't represent well the actual distance between 2 points, sometimes they fail, right? So now this is the situation, and you can go up to here. Actually, it is the algorithm which is used in Google navigation also, something similar. At each junction, you have to find where to turn. Here the cost function is turning and moving, but there the cost function in a lot of things. The distance between 2 points, the traffic levels, the road condition. I think by analyzing how the vehicles are moving on a particular road, you can get a parameter to represent the road condition and traffic level. So all these things will be considered, and at the end of the day, you will be given the best route to travel. So I hope if you keep on thinking in this line, one day you also will be able to work at such places. And this is where we need engineers, right? To provide solution to unsolved problems, right? Not to make system. For example, some of you will find, okay, for some of the existing problem, there are a lot of algorithms. But we need engineers to develop things which are not there, right? So please continue with your discussion and try to solve the original problem as well as this one, right? So if you find the original problem is difficult, keep on discussing that, but for the time being, try to find a method to solve this problem, right? Now I am going to demonstrate this and show you how it works. So at the beginning, you are here, right? So when I substitute the location and direction code of this particular state, or the state code of this particular point, my algorithm or my method should generate me these two as the allowed solution. So I will, right? So you can see it has generated these two solutions. So I have coded these mathematical equations into a computer and it is automatically generating. And then, since based on the criteria that this point is closer to the patient, it has selected. Right. Next, what will happen? Now, what are the allowed cells? This one, and this one. But since we have already traveled this one, unless you don't have any other option, right? Please keep in mind, unless you don't have any other option, coming back is not going to work, because then it will keep on taking this forward and backward, right? So the two possible solutions are these two, right? So we are not going to go to a already visited cell unless it is really necessary. For example, when you are going to a corner like this, you have to come back here, right? But here we try to avoid that. So we have selected this one because it is closer to the goal. So it goes like this, and now comes the turning action. So far we are having action number 1, which is don't turn. Now we have action number 2, which will turn, right? Again, do not turn, do not turn, do not turn, Now, counterclockwise, that is action number 4 is going to take place. So like this, it can go from, still it is not going, it is still analyzing, and after, now it reaches the patient, and after reaching it, it will find the path, like marked in red, and now the robot can follow that path, right? So it is not the robot is moving and selecting the path, but initially it will calculate the path and then save this action list. Action list means 1, 1, 1, 1. This is 2, 1, 1, 1. Right? And when you come here, it will be 4. So that action list will be saved, and whenever you come to a new tile, you will implement that action. So giving the instruction to the hardware of the robot is an easy task, right? So this is the way it works. So, but this may not be the best way also, right? So please keep on thinking, keep on discussion, because at the end of the day, what is important is bringing out that hidden hero within you, right? Remember that I told you at the very beginning, the main objective of this whole exercise, right, all these activities are to bring that hero out, because that hero is hidden within you due to various other pressures, right? So at the end of the day, what I like to see in all of you is that all of you become this. So this stands for be yourself, or be you, right? Because it is only by being you we can give better solutions which are at the moment required by the engineering profession, because we don't need engineers who can maintain the system. Actually, we need them as well, but more than them, we need engineers who can innovatively think and take this profession ahead, right? Who can see beyond what is available. Okay, so that is how engineers create the world which was never before. So I wish you all the best to achieve those targets after 4 years spending with us, and also I wish that we will be able to physically meet soon and continue with these activities. So until then, stay safe, stay discussing, and try to think differently and be yourself. Thank you very much.
Can you tell us something about your team and where are you from?
Actually, we are from Sri Lanka. Our team is representing University of Peradeniya. There are mechanical engineering students and electrical engineering students here.
Okay, great. Can you tell us something about your vehicle, especially the structure and the shape? Why did you select something like this?
Actually, This shape was used because in our university we developed omnidirectional platform technology. We thought it will be helpful with when designing this one also, because it can be controlled smoothly. So actually it worked. So it worked smoothly. So that's why we used that shape.
How about the hardware and software? Can you or your team member comment on that?
As hardware, we use brushless AC motors to control the robot. Then we use stainless steel to develop the chassis. Then talking about to the software platform, we use Raspberry Pi and simply Arduino to the control the motors. To do the tasks, we use image processing. That is done by the Raspberry Pi. Then there are communication link between Raspberry Pi and Arduino boards to control the AC.
That's great. How was your run today during the qualifying round?
Yeah, it's pretty good because we done that around 19.1 seconds. We get the 8th of the qualification round.
This semi-automatic mobile robotic platform is fully developed in University of Peradeniya in collaboration with Cogen International Private Limited by QRWorks team. This robot has some key features. The first feature is it can be remotely operated using Wi-Fi network. important thing is the health service provider can monitor the patient from a very remote place. He can stay at a remote place and operate the robot and monitor the patient. This robot has two-way audio-video communication. The health service provider receives a high-resolution video feed from a camera which can be rotated 360 degrees. It has the 10 times optical zooming. The very important feature is this robot has obstacle avoidance. That means it can avoid obstacles in its path. This feature is fully operating on board inside the robot, and it is a feature that is developing over the past 6 years in the University of Peradeniya. Also, this robot has a waterproof structure, so it can be sterilized as well in the situation. Currently, we are developing some new features also. First feature is we hope to develop the robot to a fully autonomous mode using SLAM. In this method, the robot uses its camera to generate a map. It is a replacement for GPS. Then the next feature is face recognition and identification. So it is done using a neural network. So the robot identifies the patient, recognizes the patient, and the patient's details is stored in a database. So whenever the health service provider directs the camera to the patient, the robot identifies the patient and gives the medical health service provider the necessary information. Also, other than that, there is gesture control algorithm. So it is also done by neural networks. Here, the operator can operate the robot using hand gestures. Then there is also currently we are hope to develop the follow me feature.
Please note that the material in this communication is subject to copyright under the Intellectual Property Act No. 36 of 2003. Any further reproduction or communication of this material is allowed only to the extent provided in the Act.